For notes number 16, our goal is to review the key concepts of circles. This is our last set of notes on circles before we move on to our last unit. So one of the first things we did in our circles unit is we found the measure of the arcs. So a couple things I noticed in this picture right away. I see that this is 87 degrees. So if the central angle is 87, it's exactly the same as the intercepted arc. So TU would be 87 degrees. I also notice that SW is 72, so therefore the central angle is also 72, and these are vertical angles, so that means UV is also 72 degrees. Other things to notice, whenever you have a half circle, for instance, if I create a half circle here made up of two arcs, half circles total 180 degrees. So if I know one of the arcs is 72, I just have to take 180 and subtract 72 from that, which would give me 108 degrees. So again, both of those arcs in red should add up to 180 because it's a half circle. To find the very last arc, ST, which is right here, there's a couple ways you could do that. Since all of the arcs in the circle added 360, you could add the 4 arcs that you already know and then subtract from 360. You can also look for half circles. For instance, if I highlight this half circle here, it's made up of 3 arcs. I already know 2 of the arcs. I know the 87, and then I know the 72. And if I add those together, I would get 159. And if I take 180 and subtract 159 from that, that would give the remaining arc of 21 degrees. So now that I have the entire picture filled out, I could find the measure of these 3 arcs here. So for this first arc, if it has 2 letters, UV, then my answer should be less than 180. So UV is right here. That would be 72 degrees. The next arc has 3 letters, so it should be more than 180. So I have to start at T, pass through V next, and end up at W. So if I look at how many arcs make up this green one, there's a total of 3. So I have to add 180 plus 72 plus 108, and that would give me 273 degrees. Lastly, ST has 2 letters, so it should be less than 180. Here's ST, so we already know that's 21 degrees. For number 2, we're finding the arc length. The arc length is a portion of the entire circumference. So I already highlighted arc KL, which is what we're trying to find here. And they also give us that the radius, JI, is 6 centimeters because it goes from the center to the point on the circle. So this is 6 centimeters, so there's our radius. So in order to find a portion of the entire circumference, we have a formula here. So we first have to find the arc measure in terms of degrees. If I look at my picture, I don't have the arc measure right away. However, I do notice that this half circle here that I'm highlighting in blue is made up of 2 arcs, and I already know one of the arcs. I know that this is 55 degrees because it's vertical to arc JK. So if this blue arc that I'm highlighting is made up of 2 arcs and it totals 180, in order to find the missing arc, then all I have to do is take 180 and subtract 55 from that, which would give me 125. So there's our arc measure, 125 degrees out of a total of 360. And we're trying to find the arc length, x, which is a portion of the entire circumference. So remember, circumference has a formula, 2 pi r. So 2 pi, and then the radius is 6. So from here, we're going to be cross multiplying. I'm going to grab my calculator. So we're multiplying x times 360, which is 360x, and that's equal to, we're going to be multiplying 4 numbers here in any order. So 125 times 2 times 3.14 times 6, that's 4,710. One last step to get x alone, divide both sides by 360. We're going to round to the nearest tenth, it says. So dividing by 360, I get approximately 13.1. So that means arc length KL is approximately 13.1 and the units is centimeters. For this third one, we're finding the area of the shaded sector, which is this portion here, and that is a portion of the entire area of the circle. So again, you have your formula here, setting up two equal ratios. The first thing we need is the arc measure of PQ, and here's how I can find that. I know that QR is 19 degrees because these are vertical angles. So QR is 19 degrees. And then this box right here tells me that that's a 90-degree angle. So this arc that I'm highlighting in red is 90 degrees. Since it's made up of two arcs, in order to find the missing arc, I just take 90 and subtract 19 from that, which would give me 71. So the arc measure is 71 out of a total of 360. We're trying to find what portion that shaded sector is of the total area of the circle, which has a formula, pi r squared. So they do give us the radius. They tell us that UR is 9 meters because it goes from the center to a point on the circle. So that is a radius. So plugging in pi, the radius, which is 9 squared. So from here, we're just cross multiplying, and then we're going to round to the nearest tenth. So 360 times x is 360x, and that's equal to, I have to multiply four numbers here, 71 times 3.14 times 9 times 9, and I get 18,058.14. And then the last step is to divide both sides by 360, round to the nearest tenth. So I get 50.2. So approximately 50.2 in the units is meters squared. For number 4, we're going to graph the circle. So there's two things you need. You need the center, which you can find by the equation that they gave us, and then the radius. So the center is h comma k. This is our h and this is our k, and if you remember the pattern, all you have to do is flip the sign. So if it's a -2, that means it was a +2. And if it was a -5, that means it was a +5. And the equation is equal to r squared. So you're trying to find the radius here. So the radius squared is equal to 9. So what can you multiply by itself to get 9? Or in other words, take the square root of both sides to get r alone. And the square root of 9 is 3. So the radius is 3. So the very first point I'm going to plot is the center, 2, 5. So starting at the origin, which is right here, I'm going 2 to the right and then up 5. So here's the center, 2, 5. And then we're using the radius of 3. So from this point here that I have plotted, we're going to go up 3, plot a point, back to the center, down 3, plot a point, back to the center, to the right 3, plot a point, back to the center, to the left 3, plot a point, and then connect. For number 5, we're writing the equation of the circle. So we're given the center and we're given the diameter. So we're going to plug in our center here, which is h comma k, and then we have to plug in the radius. So our center, h comma k, so it starts out x. So if you're plugging in a -4 and there was already a minus sign in the formula, it becomes a +4. So in other words, you're just flipping the sign. And that parentheses is squared plus y. And then since you're plugging in a 5, the formula has a negative. So we're plugging in a -5 and squaring it. And that's equal to, well, we need the radius. So if you remember diameter, the diameter here, if you draw that, here's our center. Diameter goes all the way across. So if all the way across is 16, how do I get halfway across? Just divide that by 2, right? So halfway across is 8. So our radius then is 8. So if the radius is 8, if you multiply 8 times 8, or if you square 8, you get 64. For this last one, we're given the equation, and we have to find the center and the radius. So again, the center is h comma k, and the pattern is you just flip the sign. So if you see a -6, it becomes +6, and if you see a +11, it becomes -11. So there's our center. What's our radius? So if you look at the formula, the right-hand number after the equal sign is equal to r squared. So 58 is equal to r squared. So how do you find the radius? Well, what's the opposite of squaring something? Taking the square root. So the radius is just the square root of 58.